There are about 100 million black holes wandering through our galaxy right now. No star, no orbit, no schedule, just drifting through the Milky Way like silent, invisible wrecking balls. Most of them will never come near anything interesting. Space is big, absurdly, insultingly big. The odds of one wandering into our solar system are tiny, but tiny isn't zero. So today, Max and Cosmo are going to watch what happens when one does. A stellar mass black hole, about 10 times the mass of the sun, crammed into a sphere 37 miles across, drifting into our cosmic neighborhood at about 45 miles per second. Max has strapped Cosmo into his seat. Cosmo doesn't know why. Cosmo will find out. The first thing to understand, a black hole is not a vacuum cleaner. This is the biggest misconception in all of space content. Black holes don't suck. They pull with gravity exactly like any other object with mass. If you replace the sun with a black hole of the same mass, every planet would keep orbiting normally. Nothing would get sucked in. Earth would be fine. Cold, dark, and lifeless, but orbitally fine. The problem isn't the black hole's appetite. It's its gravity showing up uninvited to a system that's been perfectly balanced for 4.6 billion years. Our solar system is a precision instrument. Every planet, every moon, every asteroid is in a gravitational equilibrium that took billions of years to settle. It's like a house of cards, stable as long as nobody bumps the table. A black hole 10 times the mass of our sun? That's not bumping the table. That's flipping the table, setting it on fire and leaving. Max checks the long-range scanners. A faint gravitational distortion way out past the Oort Cloud. Moving fast, moving inward. Cosmo's tail is wagging. Cosmo doesn't understand gravity wells. Cosmo understands that Max is tense and tense. Max sometimes drops food. The first victim is the Oort Cloud. This is a vast shell of trillions of icy objects that surrounds our solar system at a distance of about 2,000 to 100,000 times the Earth-Sun distance. It's the source of long-period comets, the ones that take thousands of years to orbit the sun and occasionally show up as a smear of light in the night sky. When the black hole enters the Oort Cloud, it's like throwing a bowling ball into a field of marbles. Its gravity scatters icy bodies in every direction. Some are flung out of the solar system entirely, ejected into interstellar space, never to return. Others have their orbits bent inward, toward the inner solar system, toward the planets, toward Earth. Within decades, the night sky fills with comets. Not one or two, hundreds, thousands. A bombardment of ice and rock dislodged from their peaceful orbits by a gravitational bully they never saw. Max watches the comet count climb on his dashboard. 1, 10, 40, 200. This is not normal. This is not a light show. This is the Oort Cloud being shaken like a snow globe by something that hasn't even arrived yet. Cosmo watches a comet streak past the window. Cosmo tries to chase it. Max grabs his collar. Not now, buddy. Not now. The black hole moves deeper, past the Oort Cloud, past the scattered disk, and into the outer solar system. Say it passes within 100 astronomical units of the sun, roughly twice the distance of Pluto's orbit. At this distance, it doesn't consume anything. It doesn't even come close to any planet, but it doesn't need to. Gravity is a long-range weapon. Neptune feels it first. The outermost giant planet, peacefully orbiting the sun for 4.5 billion years, starts to wobble. Its orbit, once a near-perfect ellipse, begins to stretch. Not dramatically, not catastrophically, but enough. Enough that over centuries, Neptune's path shifts, and that shift tugs on Uranus, which tugs on Saturn, which tugs on Jupiter. The Cascade H has begun. Think of it like a game of gravitational telephone. One planet's orbit changes slightly, and that change echoes inward. The effects are slow at first. Decades, Centuries. But the solar system is a connected system. Touch one piece, and eventually you touch everything. Max pulls up the orbital projections on the main screen. The lines representing planetary orbits, normally clean and circular, are starting to squirm. Just a little, like worms waking up. That's not great, Max says to nobody in particular. Cosmo is licking the screen. Cosmo doesn't care about orbital mechanics. Cosmo cares about the screen being a surface, and all surfaces are lickable. Now let's crank it up. What if the black hole doesn't pass at 100 astronomical units? What if it comes through the middle of the solar system, within a few astronomical units of the sun? This is the disaster scenario, and it's spectacular. As the black hole approaches Jupiter, the largest planet with 318 times Earth's mass, the gravitational tug-of-war begins. Jupiter has been the bouncer of our solar system for billions of years, using its massive gravity to deflect asteroids and comets away from the inner planets. It's the reason Earth hasn't been pummeled into dust. But Jupiter has never faced anything like this. The black hole outmasses Jupiter by over 3,000 times. And as it passes close, it begins to strip gas from Jupiter's atmosphere. Slowly at first, wisps of hydrogen and helium peeling off like paint in a wind tunnel. Then faster, the gas spirals inward toward the black hole, forming a superheated accretion disk that glows with X-rays. Jupiter, the largest planet in our solar system, the ancient guardian, is being eaten alive, layer by layer, storm by storm. The Great Red Spot, a hurricane that has raged for over 300 years, gets pulled apart like cotton candy. Max watches from the observation deck. He's seen Jupiter 100 times. He's never seen it scream. Cosmo presses his nose against the glass. The glow of the accretion disk reflects in his eyes. Orange, white, furious. His tail has stopped wagging. Even Cosmo knows something is wrong. And Earth? What happens to our planet in this gravitational chaos? It depends on the exact trajectory, but in most scenarios where a stellar mass black hole passes through the inner solar system, Earth has 3 possible fates, and none of them are good. Scenario 1, ejection. The black hole's gravity flings Earth out of its orbit entirely. We leave the solar system at tremendous speed, joining the billions of rogue planets already drifting through the galaxy. No sun, no warmth, a frozen rock tumbling through the void. We covered this in episode 3. It's bad. Scenario 2, orbit swap. Earth's orbit gets reshaped, pushed closer to the sun, pulled further away, or tilted into a wildly eccentric ellipse. Either way, the seasons are destroyed. The climate is wrecked. If we're pushed too close to the sun, the oceans boil. Too far, they freeze. And a highly elliptical orbit means we'd experience both scorching summers and cryogenic winters every year. Scenario 3, the worst one, direct encounter. If Earth passes close enough to the black hole, within a few hundred miles, the tidal forces would rip the planet apart. Not gradually, violently. The same spaghettification we talked about in episode 1, but applied to an entire world. Earth would be stretched and shredded into a stream of molten rock, spiraling into the black hole's accretion disk. 7 billion people, 4.5 billion years of geological history, every mountain, every ocean, every dog park Cosmo has ever visited turned into a thin ribbon of glowing debris around a 37-mile wide sphere of collapsed spacetime. Max pulls Cosmo close. We're not doing scenario 3, buddy. Cosmo licks his face. Cosmo is doing his 20%. But here's the thing, and this is important. The black hole doesn't have to touch Earth to end civilization. It doesn't even have to come close. If the black hole merely passes through the outer solar system, the comet bombardment alone could be catastrophic. The Oort Cloud disturbance would send waves of icy projectiles toward the inner planets over thousands of years. Earth would face impact after impact. Not one apocalyptic asteroid, but a slow-motion machine gun of ice and rock over millennia. 66 million years ago, a single asteroid 7.5 miles across wiped out the dinosaurs. Now imagine hundreds of objects that size arriving over centuries. Life wouldn't just be set back. It would be repeatedly set back again and again before it could recover. Max looks at the simulation timeline. Comets hitting Earth in year 200, year 340, year 1100, year 5000. It doesn't stop. The bombardment goes on for tens of thousands of years. Cosmo, I think we need to move. Cosmo is asleep. Of course he is. The comet bombardment of Earth is scheduled for a few hundred years from now, and Cosmo operates on a 5-minute time horizon. As far as Cosmo is concerned, the world is fine because Max is here and the floor is warm. There's a lesson in that. Max isn't sure what it is, but it's there. So how likely is this? Should you actually worry about a rogue black hole? The honest answer, almost certainly not. Astronomers estimate there are around 100 million stellar mass black holes in the Milky Way. That sounds like a lot, but the Milky Way is 100,000 light years across. Spread those black holes evenly, and the average distance between any two is enormous. The nearest known isolated black hole is estimated to be about 80 light years away. At typical stellar drift speeds, it would take over 1 million years to reach us, even if it were heading directly our way. And it's not. It's just out there, doing nothing, being invisible. The chance of a black hole passing through our inner solar system in any given century is estimated at roughly 1 in 100 trillion. For perspective, you are more likely to be struck by lightning while holding a winning lottery ticket while being bitten by a shark. But over billions of years, the odds change. Our solar system has been here for 4.6 billion years and will exist for billions more. On that time scale, a close encounter becomes less of an impossibility and more of an inevitability. Not tomorrow, not in our lifetimes, but someday. The universe is patient. It has time. And that's what makes this scenario so fascinating. Not as a threat, but as a reminder. We live in a system that feels permanent. The sun rises, the moon orbits, the seasons cycle. It's felt this way for all of recorded human history, which is a blink compared to the age of the solar system. And so we assume stability. We assume the orbits will hold. We assume the neighborhood is safe. But the solar system is not a closed room. It's an open field. Things pass through. Stars, gas clouds, rogue planets, and yes, occasionally, black holes. The gravitational balance we depend on is real, but it's maintained by the absence of disturbance, not by some cosmic law of protection. We're not safe because the universe is kind. We're safe because the universe is mostly empty, and mostly is doing a lot of heavy lifting in that sentence. Max stands at the window. The simulation is over. The black hole has passed through and moved on, leaving behind a mangled solar system, planets scattered, comets raining, Jupiter reduced to a glowing memory. But it's a simulation. Outside the real window, the real solar system is quiet. Jupiter is where it should be. Neptune is on track. The Oort Cloud is undisturbed. Everything is fine. For now, Cosmo wakes up. He stretches. He looks at Max, then at the window, then at Max again. His tail wags once, slowly, then faster. Max reaches down and scratches behind his ears. You know what, Cosmo? The solar system held together for another day. That's worth celebrating. Cosmo agrees. Cosmo always agrees. Not because he understands gravitational dynamics, but because Max is here, and there's a treat in his pocket, and the floor is still solid beneath his paws. And out there, 80 light years away, a black hole drifts silently through the dark, not heading toward us, not heading away, just, moving. And in invisible remnant of a star that burned out millions of years ago, carrying all its mass and none of its light. It doesn't know we're here. It doesn't care. It's just gravity doing what gravity does. And we're just stardust, sitting in the path of whatever comes next, grateful for every quiet orbit. Next time, Max and Cosmo are tackling the block universe. Is time an illusion? Does the future already exist? Cosmo has never understood clocks, and it turns out he might be onto something.